Okay. We are going to start talking about, we're going to go over some stuff about water properties. That is not going to show up on my unit test, but it will show up on the practice test that you're going to take on Friday. So don't forget your test is Friday. That'll be the last of the new material we're covering. We're going to do a little quick lab today where you will be learning how to design an experiment. So we'll walk through that together. I just want to show you a couple things for reference. I have a feeling we're going to start having more people having to work from home again. I have generated a Meet link here on Classroom. So just let me know if you know you're going to be out and you want to participate. Just let me know so I can make sure I've joined. But that's an option if you do need to work from home. Today's kind of a crazy day. We've got a lot of different things we're doing. And so some of the people that are gone today are joining that way. Okay. One thing to see on AP Classroom, I love that it logs me out occasionally. So we get to wait while it loads. So you're going to be taking the practice test on AP Classroom. It was all logged in the last time I was on this tab. Okay. So we are going to start using this a little bit more as we go forward. One thing I wanted to call attention to you for, I'm going to give you one more try, and I'm going to go the other way. There are a series of videos that they show you. Here we go. So hopefully your screen looks like this if you're in AP Classroom. This is our first unit. I'm going to go in the same order that the College Board goes in. So first unit is Chemistry of Life. It shows you all of the unit topics. Okay. It gives you a daily video that people who work for the College Board have recorded. So you are always welcome to watch that. Topic questions or questions that you can look at just for practice. The unit guide here is really helpful. Okay. It looks like this. It tells you exactly what you're responsible for knowing. Let me do this. So this is our first unit. It gives you exactly the topics we're covering. You don't have to worry about instructional activities. And then here for each of these topics, it tells you exactly what you're going to be responsible for knowing for that topic. So if you're somebody that likes to be really organized and know exactly what's expected of you, those are good things to look at. So you can open that just by clicking on this link here for unit guide. Okay. All right, so let's go ahead and open up the water properties lab that is linked on Classroom today. So let's put our phones away and focus on what we're doing here. Okay, so we're going to be reviewing kind of how to set up an experiment. We're going to be doing it in the context of determining how many drops of water you can drop onto a penny before the surface tension breaks and the water expands out. Okay, so we're just kind of seeing how to design a good experiment. So we're going to do a quick review of experimental design. So this video here. Braden. Is Braden here? Okay. I have not taken attendance yet. It's probably something I should do. Okay. So we are going to watch the first few minutes of this video. I'll get it started.
Now we're going to continue on with section 1.3 today and wrap up chapter 1. Now 1.3 is going to focus on how do you ultimately go through the process that we would consider experimental design. So whenever you're trying to test something, you need an experiment to test it. So we're going to focus on what are the parts of a good experiment. We're also going to talk about how you represent and analyze the data that you get from an experiment. So starting off, let's go over some terms to make sure you're comfortable with them. So when you're doing an experiment, one of the first things that we typically want, what is present in most good quality experiments, is a control group. Now the whole purpose for a control group is to have a group of individuals that we are going to not test. We're going to kind of leave them normal. We're not going to manipulate them. And we're going to use them for comparison. So for instance, if I think coffee stunts your growth, makes you shorter, I need to know how tall people are on average that don't drink coffee. So that way I can have an experimental group, that's going to be these guys, the ones that you manipulate, where I might say, all right, I'm going to have a group of these guys that drinks 1 cup of coffee a day, maybe another group that drinks 2 cups of coffee a day, and I'm going to analyze their average height. And then I can compare their average height when they drink coffee, depending on how much, with what it would have been most likely if they didn't. So now I can get a sense of, are they actually shorter than they would have been, or are they taller, or are they about the same? Now, some labs will not lend themselves to having control. Sometimes, basically, everybody's being experimented on. But if possible, if you're able to have a control group, you should always try to have one. That way you can set a baseline so we can figure out exactly how much something changes. Now, next, we've got a series of variables. So the independent variable is what you are going to change. So this is sometimes referred to as the cause. This is ultimately what the experimenter is going to be changing. So in our experiment from up here, that would be like the amount of coffee you drink. So this is independent.
All right, one thing you want to be doing is there's the first 3 questions on the that lab that you should be answering as he's talking.
Everything else, this is just up to me as the person designing the experiment. I'm going to say, all right, you drink no coffee, you drink 1 cup of coffee, you drink 2 cups. It's under my control. Now, the fact that people are drinking different amounts of coffee should cause some effect. And that effect is going to be our dependent variable. So this is what I'm going to measure, and that's what I'm going to put down here. This is essentially what's being measured to try and see what might change, the independent variable being changed, what effect that has, what it cost. And so in this scenario, the one that we did with coffee, so this would be a coffee, okay, coffee drink. And then below it, our measurement was going to be height. And because you do this with a lot of people, you'd normally take an average that. Because we can't just look at one person, we need a group. So that's going to be the basic ways that variables work, at least for our 2 main ones. Independent variable, what are you going to change? Dependent variable, how are you measuring the effect that that change had? Now, constant variables are typically every other variable in a lab. And that constant variables are just ones that are unchanged. So if I'm trying to do the coffee experiment, I would want to make sure that there's not other things going on that affect their ability to get taller. So I'm trying to make sure that they don't get injured. I ideally like them to drink the same amount of water, to drink the same, or eat the same types of foods in the same amounts. So ideally, the rest of the variables that we're not experimenting with, we try to keep them the same, constant, unchanged. So those are oftentimes referred to as constants or constant variables. Now, confounding variables are ones that we know can mess things up. So these are things that could occur, like we talked about, where maybe some of them are eating some other food that's known to cause stunted growth. Maybe some of them aren't eating enough food, which could stunt your growth. Maybe some of them have injuries. So these are things that ultimately can, and not being as elegant as perhaps I could be, I'll just say it can mess up our data. So these are variables that could affect our dependent variable, that could affect our measured results, but they're not what we were studying. They're not the independent variable. They're different. So mess up our data is ultimately what these guys can do. And so a lot of times you'll see someone say that in their experiment that they adjusted it to remove confounding variables. So if they knew some guy ate not enough, they might take and either remove that person from the study, or they might adjust his height to be higher, so to speak, to adjust for the fact that some of that stunted growth was because he didn't eat enough. So examples, I just want to make sure you guys can identify.
Okay. Once again, we are recording. Okay, so what is the difference between a control group and the experimental group? What's an easy way to remember that? Control group is what you don't change. What do you mean?
Like, you don't mess with the knowledge, it's not manipulated.
Okay, you're not giving it a treatment. You're not doing anything to it. That's just show that the treatment that you're giving to the experimental groups is actually having an effect. Okay, so what is the difference between an independent and a dependent variable? What is a dependent variable? It's based off of what? Okay, so you're changing the independent and the dependent changes in response. Okay, dry mix is a really good thing to remember there so that you remember that which goes on which axis of a graph. So dry, the dependent or responding variable goes on the y-axis. And mix, the manipulated or independent variable goes on the x-axis. Okay, the difference between a constant variable, the variables that we're keeping constant. What are we trying to do there? Why do we need to keep variables constant in an experiment?
Make it fair.
Say it again.
Make it fair and equal, like, just so like they won't change, like temperature will change from they're just going to check them to keep it like equal throughout.
Okay. To make sure that everything is kept stable, so this change you're seeing is because of the things you're changing, not because of other stuff. And so those confounding variables are the things that you may not realize are having an effect. And so you want to make sure that as you're designing your experiment, you're controlling for those as well, making sure that you're reducing those other variables. Okay, so you are going to be throughout the year designing most of your labs. So the lab we did in chemistry, that was one that you had a procedure and a whole bunch of steps and you followed it very precisely. There'll be a few experiments like that throughout the year. The majority you're going to be designing. And that's a difficult thing to do. It's difficult to design a good experiment. And I think part of the problem is that you have this idea that you can sit in the classroom and design an experiment and then go in there and it'll work. How science actually works is that scientists do experimenting as they are making their procedure. So they're not collecting data that they care about during that time, but they're testing out different procedures to eliminate those confounding variables and to make sure that what they're doing is actually, the data that they're going to get works. Okay, so whenever you do have to design an experiment, there will be some time for you to play around with the equipment and to see what's there and figure out what you want to do and really make your experiment good. Okay. So today we are going to see how many drops of water your penny will hold before the surface tension breaks. Then you are going to see how it works differently. Can you have the same number of drops if you're using a different liquid or a solution with water? So when I talk about solutions, that's going to be mixing something into the water, dissolving something into that water to make it a solution rather than just water. Okay. So we talked about this. Okay, so a procedure needs to be extremely detailed and thorough. Okay, I really need you to be focusing on what we're talking about today in class and not on your phones. Okay, so a procedure needs to be more detailed than lay the penny on the table, drop water on the penny, count how many drops it fits before the surface tension breaks. That's not specific enough. Okay, you need to think about all the variables. So I've given you a list of things to think about as you're designing that experiment. So you need to think about which kind of dropper. I've given you a lot of different droppers in the lab to pick from, what type of water you're going to use, where you're resting your penny on. Okay, how high you're holding the dropper above the penny. Is that going to make an effect? How fast you're dropping. Are you using the same person each time doing the dropping? How are you recording your data? How much solute are you putting in your solution? Is it reproducible, what you come up with? Can you do it over and over again? How many trials do you need? What temperature is the liquid at? Okay, so let's look at our properties of water. Hopefully you went through this in biology, and these may be the actual slides you used because I took them from somebody because I didn't have a presentation ready. Okay, so polarity, this is our main reason why we have the water has all of these properties that we're going to be looking at. And that's because, and we talked about this before, water is H2O. That oxygen has a lot more protons in the center, in the nucleus, than the hydrogen atoms do. And so they're going to have more attractive force of those electrons that the hydrogen and the oxygen share, okay? Because they have a covalent bond, so they're sharing their electrons. So those electrons spend more time rotating around the oxygen than they do rotating around the hydrogens. Okay, so that oxygen ends up with a slight negative charge on that end. And the hydrogen end of water, you can see here, has a slight positive charge. Okay, so this is polarity. This is why all of the other things we're going to talk about here in a minute happen, is because of this polarity of water. Okay, so because of those slight positive and negative charges on these polar water molecules, they're going to form something called a hydrogen bond. Okay. That hydrogen bond is not the same kind of bond that you're going to see in a covalent bond. It's got a slightly different structure. It's got a slightly different strength, so to speak. Okay. So you're going to have that bond form. Cohesion. So cohesion is a property of water that's due to polarity, and that's going to, it's basically those hydrogen bonds are forming, and so the water is going to stick to other water molecules. Okay, so they're going to form droplets like you see here on this leaf. Okay, so cohesion is also going to cause something called surface tension. So on the surface of water, those water molecules are going to be cohesive to one another, and so they're going to have a little force here that's going to keep things from entering that water if they're of a certain mass. So you can see here this paper clip is floating on water. This insect is walking on the surface of water because the force of their legs does not break the force of that surface tension. Okay, so this is really where what we're gonna see is we're dropping water on the penny. Adhesion is going to be two different substances that are sticking together. And so when we have let's say a glass slide and we're dropping water on that water is going to stick to the slide and to the rest of the water. Okay, so cohesion and adhesion work together, and that's how capillary action works, if that's one that you've talked about. So inside of plants, they have these really narrow tubes, and that's how the water is going to go from the root up to the leaves, okay, through capillary action, where the water's sticking to itself and it's sticking to the sides of the tube, and it's going to raise all on its own without any extra energy being added. All right. So what is the science concept that we are exploring today? So from that, what do we think our science concept is today? Okay, what about water? Properties of water, what specific property of water? Okay, polarity, because it's the basic property that causes all the other properties. Cohesion, okay. Surface tension, all of those things are essentially the same thing. Okay, they're all related. So any of those you can talk about when you're answering this question. So why are we looking at water and an alternate solution or liquid? What's the purpose of looking at something besides water? Okay, to see how when we make a solution, does it change that cohesive ability of water to stick to itself? Or if we use a different liquid, is that is the same kind of polarity, and will you have the same kind of surface tension and cohesion? And I did not attach a spreadsheet. That's okay. Okay, so we are not going to be collecting formal data during this experiment. You will create a data table that you would use if you were going to carry out your experiment. So you may want to bring some scratch paper with you when we go into the lab so that you can kind of make notes as you're going to refine that procedure. So like this many of drops, I could be consistent using this height off the table and this kind of thing, just to kind of help you keep track. Okay, so once you get into the lab, you're going to wash your hands and then go get a pair of goggles. We got our visor goggles in. They are much better. They will probably give you a line right here on your face, but I don't think they'll fog up as much. So I'm excited about that. Then once you're kind of settled in, take a minute, look at the supplies on the supply table. So start thinking about what you want to do, grab different types of droppers, figure out what solution you want to make or what liquid you want to use. Then I've given you a box here to write your procedure in. I would think of it as something that you are editing as you go. So when you're typing, don't think of it as this is the final draft of this. Write things down as you go and then edit as you see, okay, that didn't really work. That was not consistent, and so on. You want your procedure to be something that somebody that knows nothing about science could come in and do your same procedure the same way. Okay. Here it says I attached a spreadsheet. I forgot. So just open a Google sheet, and on that sheet, you'll create your blank data table. So this is probably the last thing you'll do. Once you've kind of figured out what your procedure is going to be, then design your data table. Then you'll take a screenshot of that data table and put it in the background of this. Okay. You won't actually be collecting the data formally. You'll just be writing as we go. Okay, so I have some people on Google Meet. So I need somebody to join and share what they're doing. Anybody want to join the Google Meet and work with the people that are joining us from afar? I'm going to pick you if you don't. Okay. Vivian, if you will do this for me, I would appreciate it. So on Classroom, we've got that link. Just go ahead and join. And then once we're in the lab,